operations that produce equivalent system. Each of these operations on a system of linear equations produces an equivalent system. 1. Interchange two equations. 2. Multiply an equation by a non-zero constant. 3. Add a multiple of an equation to another equation. So example number 7, we want to use elimination to rewrite a system in row epsilon form, and after that we can able to solve. So we did example number 5 and number 6 above, and we review first. Let's review the rows epsilon form first. Now let's look at example number 6. I copied from before. So you can see that the first equation we all have x, y, and z. And what happened to the second one is the x eliminated. And then the last one, we can see that both x and y eliminated. So this is called the row epsilon form, and we want to make that for example number 7. We will use 1 or 2 or 3 operation on each step. Okay, so first of all, we keep the first equation, okay? And we want to eliminate x. We want to eliminate x, and if you pay attention that x is eliminated in both equation number 2 and number 3. So we want to eliminate this x and this x, okay? So how do we do that? So the second one, you can see the coefficient for this x is -1, and we have here is 1, so they're already opposite. So what I'm gonna do is all I do is add the first one and the second one. Okay, I'm gonna name 1 and 2 and 3. So I will add number 1 and number 2, and I will get 0 for the x, so the x eliminates, so I get y plus 3z equal 5. Okay, so I name this one is number 4 equation. And then I look at number 1 and number 3, right? I want to do R2 also. But what happened is that the x coefficient for the x is 1 and the coefficient is 2 for the third one, the third equation. So I want to multiply by -2 so that I get -2x, and add the positive 2x, it will eliminate the x for me. So what do I do is I will multiply the first equation by -2. Okay, so if you want, you can write down the first equation multiplied by -2. So it will become -2 plus 4y, -2x plus 4y minus 6z equal -18. And then write down the third equation again. And then we add them up. The x eliminate for us, so we get -y minus 1z equal -1. And I name this is equation number 5. So I got equation number 4 and 5 where the x eliminate. Now let's put them all together. Okay, so we keep the equation number 1 because we want them all x, y, and z. Okay, so this is equation number 1 again. And then we write down equation number 4 where the x get eliminated. And equation number 5 where the x also get eliminated. Okay, so we got the new system. Okay, so that is our first step. So this is our step number 1. Step 1 is we eliminate the x for equation 2 and 3. Then our step number 2 will elimination the y for the third one. Okay, so we want to eliminate this. And of course, it will be easier for us just to use 4 and 5 because we already take care of x. The x is gone. Now we want the y is gone. We want the y eliminate. I will just, all I need to do is I add 4 and 5 because I see the y are opposite already. So if I add, I will get 2z equal 4. Okay, and then I can solve for z also. So z equal to 2. Then I name this one is number 6. Now I write out the whole system again. So this is my whole system before, right? But after I eliminate the y part, so this is new, it's changed. So my new system should be x minus 2y minus 3z equal to 9. You always keep the first one. Y plus 3z equal to 5. You keep the 4 because you don't do anything with the 4. But you want number 5 changed to number 6. And it's equivalent to z equal to 2. Okay. Then you can do the substitute back in. Okay. So z is 2. Then to solve for y, you plug into, so number 4. So you will get y plus 3 times 2 equal to 5. So y is negative 1. And you have z, you plug into the first one. So x minus 2 times negative 1 minus 3 times 2 equal to 9. So z plus 2 minus 6 equal to 9. Z minus 4 equal to 9. Sorry, I have the x right here, right? And I make some mistake somewhere. So y is negative 1. So I have x plus 2 and I should have plus right here from the beginning. So I have a plus right here. Sorry for that. Plus right here. Plus right here. Then plus 6 equal to 9. Then x equal to 1. Okay, so let's look back in and we see what we did. So what we did is we use the multiply an equation by a non-zero constant. So that's what we did in this part, right? So we multiply by negative 2 and add a multiple of an equation to another equation. So we did. So we add them up. Okay, so we use number 2 and number 3 for this problem to solve.